This recording is for Algebra 1, Chapter 4, Lesson 2, Relations and Functions. A relation is a set of ordered pairs, and ordered pairs from the last chapter, or from the last lesson, is things that can be graphed on a coordinate plane, so usually an x and y, right? Okay, so the domain of a relationship is the set of the first coordinate point, so usually the x, right? In an ordered pair, we have an x and a y, right? Well, the domain is the x, whereas the range of a relationship is the set of second coordinates, in this case y. So basically we're taking an ordered pair and kind of splitting it and looking at half the information, usually the x's, also called the domains, and then looking at the y's, also called the ranges, okay? And so again, x would be the domain and y would be the range. And so a relation would be a bunch of these ordered pairs where we'd split them, where we're looking at just the x's from the ordered pairs and then just the y's from the ordered pairs. So, and in a relationship that assigns each value in the domain exactly one value in the range is called a function. So there's other types of ways of looking at this. We could also look at like other relationships where like we have age and height, where age would be the domain and height would be the y. So there you go. There we go. Okay. So we can also look at time and distance. So time would be the domain and distance would be the range, and the relationship between them would also obviously then be the rate, how fast you're going, because the longer you go at a certain rate, the further you're going to go in distance. All right, so there you go. So x's and y's. So if we're looking at to find the domain and range, sometimes the information will be given to you as a chart, and you just write all of the x's in from least to greatest without repeating any. So if there were like two -4s in the x's, I wouldn't write both of them. I would just write one of them. So the domain for x in this relationship here on the left is -4, -2, 3, and 5. Whereas the range is -1, 0, and 3. So see how I didn't repeat the second 3. There's only really one 3. It just happens to be assigned to two different x's. And this is actually what we call a function, because each value of x has its own value of y, even if the value of y is repeated. So -2 can have 3, and -4 can have 3, as long as -4 doesn't have a 3 and, say, a 2. Okay, so as long as the value of x only has one y, even if it's a repeated y, it's okay. All right, so, and we're going to look at other ways to visualize this in just a second. So let's go ahead and look at the second one here on the right. We have a domain of, yes, that's a function. They're in blue. So we have a domain of -3, 6, and 8. So see how I didn't repeat the two -3s. I only wrote it once. And then the range is -2, -5, 4, and 7. So in this case, -3 has two values for y. It has -5 and 4. This means it is not a function, okay? Because the x can only have one value of y. All right. So there we go. All right, so here's a mapping diagram, and it's going to help you determine if it's a function. It's another way to write it. Basically, I've written all of the domains. It's just another way of, writing. Let me get my pen. Domain, and then, having the ordered, the numbers. So it would be like, 6.5, 7, etc. This way, you line them up still in from least to greatest. And then this for the domain and the range, and you don't repeat any numbers. So I didn't write the -1 twice for the range. Didn't write that twice. See, it's only there once. And then I'm going to connect the range that is, or the domain that is associated with the range with a line. So I've already done 6.5 and 0. So 6.5 and 0. And then I have 7 and -1, 6 and 2, and 2 and 6, and 5 and -1. So it's totally okay that 5 and 7 share the -1. It would not be okay if 5 went to two other ranges though, okay? So this is actually a function. Yay, function. Okay, so here's another example. See again that I haven't done any repeats. You see how there's two 3s here in the range? well, I only have two 3's in the domain. I didn't repeat them when I did my mapping diagram because I really want to see how this works out. So I'm going to start connecting the numbers. 3 with -2, 8 with 1, 9 with 2, 3 with 3. Oh, automatically, since I have two numbers coming off of my 3 in the domain, 3 going to -2 and then 3 going to 3, this is automatically not a function. Okay? And then obviously there was a -4 and a 0. So this is not a function because the domain has two different ranges. So not a function. All right. Now, there's a way to test if something's a function without recording the domains and ranges if it's already graphed. So a way to determine if a graphed relation is a function is to perform a vertical line test. So if you can hold up a pencil or a ruler and it needs to be going up and down, it can't be going left to right. So up and down, and you're going to pass the pencil or ruler, or even you can use an edge of paper as long as it's straight, and you're going to pass it along, and it has to be parallel to the y-axis. You're going to pass it along the graph. If you can cover up more than one dot at a time, or more than one part of the graph that is being graphed at a time, like say 2 points or 2 parts of a line at the same time, that means that it is not a function, okay? So anything that's right on top of each other means that what's being graphed is not a function, all right? But if you can cover up only one thing at a time, then it is a function. And I can demonstrate this more in class because it's kind of hard for you to see my stylus moving across my iPad when it's not being recorded because it's not being videotaped from above. Anyway, all right, so let's move on and we'll discuss this more. Okay, now there are 4 different things that I'm going to have you determine the range and domain for on a graph. Some of them are really easy, some of them are going to involve a little bit more thought process, just bear with me, okay? And that's just points. Again, you can use a vertical line test, or you could write down the domain and range for all of the points and then do a mapping diagram, or you can make a chart to help you see if it is. But usually if you're looking at something that's already graphed, using the vertical line test is the quickest way to do it. I'll show you a straight line, I'll show you a circular shape or oval shape, and also a parabola. And now a parabola is something we're going to see more in the next couple chapters. It's something that's kind of a U-shaped, either upside down, right side up, left U, right U. You'll see some more. But for right now, you just need to know how to write the domain and range for all of these things. Okay, so we have points to determine. So if you take your stylus and make it parallel to the y-axis, and again, this right here is the y-axis, so if you make it parallel to that so that your stylus or ruler is straight up and down and you move it from left to right or from right to left, can you cover up more than one dot at a time? I hope you're doing this with me because yes, you can. These 2 dots, and actually I can kind of show you. So if I use a red line here, and I move it from left to right. Oh, that could be done a little better. There we go. So I'm covering up only one dot with that line. Okay. Now, what about this one? Because you see, this is a vertical line test. I'm only covering up one line or one dot. And if I do here, I've now officially covered 2 dots. So automatically, just from looking at this, it doesn't pass the vertical line test, and there's one more. But because of these 2 dots right there, it doesn't pass the vertical line test. Okay, so we can even write the domain. Well, the domain is going to be -3 because as I'm looking at the x-axis is going to tell me the domain. I have a number at -3, or a dot at -3. Let me use a different color. I've got a dot at -3, I've got a dot at -2, I've got a dot at 1, another dot at 1, but remember I don't repeat when I'm writing the domains, and I also have a dot at 3. Okay, so now when I go look at the ranges, I have now the ranges have to do with the y-axis. So I've got a dot at -3, a dot at -2, -1, 1, and 3. Okay, so those are the domain and range, but again, we already knew it wasn't a function because it didn't pass the vertical line test. Okay, let's move on. Okay, Determining the domain and range of a straight line is really easy. As long as it's straight, the domain and range are all real numbers because this line goes on forever. It started at negative infinity on the x-axis and went to positive infinity on the x-axis, right? And this is the x-axis, right? You guys remember this, right? So the domain is set of all real numbers. It could be anything. It could be pi, because pi is, goes on forever. It can still be pi. You can graph, well, technically you can graph 3.14 and so on. And this line will have a point at that place on the x-axis. It could be, well, here's 3.14 approximately, right? That's not 3.14, that's 2 point something. 3.14, it's up here, right? So it's got a y and an x at that point, right? And it can go on forever in both directions. So the domain is all sets of real numbers. And the range is the same. It goes on forever. So if I'm starting at, -4 on the y-axis, or on the y-axis, it does have a point that comes down off of the x-axis. So it is all real numbers. Okay, and this is a function because if I, pass the vertical line test, all the x coordinates are going to have only one y relation, one y that goes with it, one assigned y. And so it does pass the vertical line test, passes the vertical line test, awesome. All right, and then we have something that is circular or oval shape, all right, something that's round, and not just a parabola, because parabolas kind of have a rounded shape to them too. Okay, so this one doesn't pass the vertical line test. The moment you start moving your line across something, well, it kind of looks like it only hits 1 point there, but it definitely hits 2 points there. So this is automatically not going to pass the vertical line test. But we still need to figure out what the domain and range are, okay? So the domain and range is basically going to be the minimums and maximums based on the x's and y's of the circular shape. So the domain is going off of the x-axis. So this is basically where the oval stops, here and here. Well, that's basically going to be -3 and +3. So the domain is between those. So for the domain, and this is how we write it, guys. Look at this notation. This is very specific notation. Make sure you're on that, okay? So it's -3 is less than or equal to x, which is less than or equal to 3, because basically you're just in this area. It's never going to be outside of that area, okay? So let me see if I can get rid of this. Oh, nope, I can't. Okay, so let me erase this. Oops, I can't do that. Okay, so let's just talk about the range with those domain lines still on there. So the range, let me use a different color. Let me use pink. The range is also going to be the maximum and the minimum of what's going on here, but on the y-axis now, not the x-axis. So the y-axis taps out at 3. Oop, I have the line in the wrong spot. There we go. That's really where the circle ends. So it taps out at a +3 and ends at a 0. So this is the minimum and maximum of the circle and of the range. So the range is going to be y, where 0 is less than or equal to y, which is less than or equal to 3, because that's where it maxes out. It doesn't go any further. And we've already said it's not a function because it doesn't pass the vertical line test. All right, last thing I need to talk about is parabolas. Oops, I gave away the answer. Oh, no, that's okay. Okay, so very much like circles, the parabola has kind of a rounded shape, but depending on which way the parabola goes, it can be a function, it might not be a function. Already passing the vertical line test, just because if I, here's my vertical line test with the pink lines, I am never covering up more than 1 point on the line at any given time, right? So let's see if I can, no, that won't work. Let's see here. Okay, but we still need to figure out the domain and range. So the domain, since this parabola goes on forever, it kind of looks like it kind of just stops. It does keep going on forever, and we know it goes on forever because of these arrows. So the domain is all real numbers because it can be anywhere on the x-axis, whereas the range, it kind of stops. You guys see how it tops out right here? That means that the range, it's never going to go past 2 up here, which means it's everything below 2. So y is less than or equal to 2 for the range. And we already talked about it passing the vertical line test, so that's good. But just real quick, I want to show you one more parabola. I'm going to do this one in black. I don't know. Let's do it in an obnoxious yellow. Okay, not obnoxious necessarily, but something that you can definitely see. What if I had a parabola that looks like this? Right. Well, does this one pass the vertical line test? No, it doesn't. So not all parabolas are going to pass the vertical line test. So therefore, not all parabolas are functions. So you do need to keep an eye on that. All right, I'm going to stop because this has gone on long enough. Thanks, guys, for being patient, and I hope you learned a ton about functions and relations. All right, bye, guys.